welcome to Varma's Chem. Hey, you may not be watching this in the morning, but good morning, my time, in New England at least. And I call this Science on a Saturday. I'm so glad you're here. I'm so glad you're watching. Good to have you here. This video is going to be about the mole concept. Now, as I'm talking about it, by the way, if you're one of my students, a warm welcome. If you're watching on the internet, a very warm welcome to you too. Super important. You've got to participate in this. So you've got to take notes. I would recommend a composition notebook. The title of what we're going to be talking about is the mole concept. From time to time, I'm going to ask you to write something down. Make sure you write it down. It's going to help you when you review for a test and just learning this material. It is central to chemistry. So when we talk about 12 eggs, I don't have a carton of eggs to show you, but when we talk about 12 eggs, it's a dozen. When I say, hey, I want a dozen eggs, you would fish out 12 eggs for me. If I said I want a dozen donuts, you'd get me 12 donuts. Okay. If you have two sets of shoes or two shoes, you'd say it's a pair. Okay, so two of something is referred to as a pair. So hold on now. So a mole is this enormously large number. It is this number right here. So in your notes, you need to write down, first of all, the title should be Mole Concept. You need to write down what 1 mole is. So 1 mole is equal to 602 followed by 21 zeros. It is a big number. Now another way to write a mole, so there's a shortcut we use. So we don't write 602 followed by 21 zeros every single time. We write it in exponential. So I'm going to, and don't get worried about it because it's going to look somewhat terrifying when you see this number, but it's a breeze. You guys will get this in no time at all. And I'm going to walk you through this step by step. So you should have written this down. And the next thing we do is we write the shortcut, 6.02 times 10 to the 23rd. Okay? This is a shortcut for this number right here. So let me talk about this really quickly, and this number is also called Avogadros number. One important thing, a mole is not a molecule. So don't get confused by this. You've got to remember this. Some people will see mole and they'll say, hey, that's a molecule. Not so. A mole is never a molecule. Okay? So and it's just a number. You tend not to use it in everyday things just because it's such a large number. So when somebody says you've got a mole of something, you've got to immediately think, okay, wait a minute. If somebody says a dozen, it's 12. If somebody says a mole, it is 602 followed by 21 zeros. Or you can say 6.02 times 10 to the 23rd. Either one works. But a mole merely refers to a number. So if somebody says to you, tell me what a mole is, and you say 12, that would not be correct. So right here, okay, I happen to have 12 pens, 12 highlighters. Let me get those close so you can see them. Hoping the camera can focus in on that. Okay, so those are 12 pens. You'd call that a dozen. Just that simple. So you've got 12 pens, you call that a dozen. In the case of a mole, this number right here also has another name. Okay? And it is called Avogadros number. So this number right here has another name, and it is called Avogadros number. Guys, and that's not hashtag, okay? That's number. So you've got to remember this. So if somebody says, what is Avogadros number? It's 6.02 times 10 to the 23rd, or 602 followed by 21 zeros. So it's this big number. And you absolutely need to memorize this number, the 6.02 times 10 to the 23rd. And it refers to a mole. Super important that you remember this number and learn this number. It is, and so you should have written this down in your notes. You should have 1 mole is equal to 6.02 times 10 to the 23rd. You should have also written this number down. Now, real quick, this is called scientific notation when you write the shortcut. the 6.02 times 10 to the 23rd. I'm going to show you how you go from this big number to 6.02. If you know this, great. I still want you to write this down in your notes. It's good practice for you to know how you derived this shortcut number. So your decimal is sitting right here, and your goal is to try and go from here, and you want to move that decimal all the way over until the decimal lands in front of 1 and the first non-zero number that shows up that is between. So let me try and do one thing at a time. I'm moving this decimal over, and I'm going to be moving this over a lot of spots. Okay. So right now I'm almost at the 602 if you're watching this. Okay, but I need this decimal in front of the first non-zero number. This is the third. So here we go. 1, 2. Okay, so when that decimal lands here, 6.02, we have moved the decimal 23 places. Let me repeat that. The decimal has moved from here all the way out to here. It's moved 23 spots. That's where the 23 comes from. So let me write this again. 6.02. We got that. We moved the decimal there. And we multiply this by 10. And we write the number 23 because the decimal moved 23 spaces. This is a very important part of this. That is a plus 23. When you move from right to left, when you are moving that decimal from the right to the left, that number is going to be positive. In chemistry, there are going to be instances where you move the number from left to right. Okay? That's not going to be positive. So in this example, we're moving from right to left. Because we're moving from right to left, that number is a positive 23. Please keep that in the back of your mind when you're deriving scientific notation. So the shortcut is nothing but it's a shortcut for this very long number called Avogadros number, the 602 followed by 21 zeros. And this is how we use it in chemistry. So make sure you write this number down. Make sure you wrote down how I move the decimal from the right all the way in front of the 6. So we figured out that a mole is a big number. It's 602 followed by 21 zeros. Now, if I told you, okay, that I had a mole of pens right here, that is a huge amount of pens. It is an enormous amount of pens. A dozen is 12. That's what we've got here. But if I said to you, we've got a mole of pens, just so you understand how big this number is. If I took these 12 pens and I started stacking them up, one on top of the other, the height of the pens, of these pens right here, if I had a mole of them, that's 602 followed by 21 zeros of pens, I would go to the sun and back. Let me repeat, to the sun and back 200 billion times. No exaggeration here. So that is just an enormous amount of pens. Let me give you another example. Okay? I've got some washers here. Let me see if you can see you should be able to see these washers pretty clearly. So these washers right here, you've got 12 washers. The 12 washers would be considered a dozen. If I had a mole of washers, you got to understand this. So this is one washer. If I had 602 followed by 21 zeros, so 602 followed by 21 zeros of washers, one mole of washers, I would end up creating a planet of washers. The planet would be about the size of Earth. So again, it doesn't work for something this large because it's just not something we'd use. And first of all, I couldn't afford that many washers, and I'd be creating a planet the size of Earth with these washers. But, let me show you a mole of aluminum right here. This is a block of aluminum, and in this block there are exactly 602 followed by 21 zeros, a 6.02 times 10 to the 23rd number of atoms in this block of aluminum right here. I'm hoping this is focusing on it. Okay. Now let me show you copper. Here's a block of copper, a little bit smaller. It's much heavier. I know you can't feel it watching this on the internet, but that is 1 mole of copper atoms. Smaller than aluminum. But the reason this works is because atoms are so small, so teeny tiny, that they can actually fit in here. Okay, and that is 602 followed by 21 zeros, or 6.02 times 10 to the 23rd atoms of copper. Let me show you one more example here. This is a block of iron, Fe on the periodic table. That is 1 mole of atoms of iron. And so we can use a mole effectively in chemistry because it is so incredibly small. So I just showed you 3 elements, but a mole is used to represent much more than elements. You use it for compounds all the time in the lab. Let me show you a mole of salt. Now, I put it in something called a Falcon tube. That's sodium chloride. Okay, that is table salt. And I'm hoping this focuses on it. You can see how much salt is in 1 mole right there. So that is 1 mole of table salt. And I'm actually going to dump it in here so you can get a good look at it. Okay, so this, again, this is 1 mole of table salt. And I'm going to just pour it out here so you can take a look at it. That would be 1 mole of NaCl right there. So you've got the iron, you've got the copper, and now, believe it or not, you've ended up with 1 mole right there of aluminum. Doesn't have to be a solid either. You can have a liquid, and you can count the number of molecules. So here we've got 1 mole of sodium chloride salt molecules. It's technically not called molecules, but it doesn't matter for now. That's what it looks like. So let's take a look at water next. Okay, so this guy, I don't want to spill this stuff everywhere, but here we go. I'm going to show you what 1 mole of water looks like. So right here is 1 mole of water. Okay, it's this right here. It's about 18 milliliters. Okay, and that, if I pour it in, here is what 1 mole of water looks like, right there. So again, I just poured that in here, but that is 1 mole of water sitting right there. Now this is important to understand because students get confused by this. This is a model of what a molecule of water looks like. At this point, I don't need for you to understand what these different parts are. That's an oxygen, that's a hydrogen, and this angle becomes very important. That's a video for another day. But this is a model of 1 molecule. Now, students get confused by this. You might. I want to make sure you're very, very clear on this. This right here, there's 602 followed by... Now, this is a model. This is huge. But, so a real water molecule is only about 270 picometers. So it's really, really tiny. And there are 602 followed by 21 zeros, I'm losing track of all the zeros, or 6.02 times 10 to the 23rd of these guys in here. So when I set this molecule in here, it's not that there's 1 molecule. There's 6.02 times 10 to the 23rd of these guys in that pool of water right there. And so you absolutely need to understand that when you see models, okay, a lot of students will say, oh, there's 1 of these in here. That's not true. This is representing a very, very small molecule. This in itself is pretty big. You can see it. An actual molecule of water you're not going to be able to see. And there's 6.02 times 10 to the 23rd of these guys in this. So what I would like you to do is draw that out and show it to the 18 millimeter mark the way it was, and then see if you can draw a whole bunch of these little guys and make sure you indicate that there are 602 followed by 21 zeros. So 6.02 times 10 to the 23rd of these in this container in this much water. So that is the deal. So you've got different metals. So we've gone over sodium chloride, 1 mole, looks like this. Okay. 1 mole of water looks like this. I just poured it into a weighing boat, but that's what it looks like. You've got the 3 metals. I showed you a mole of copper, a mole of aluminum, and I showed you a mole of iron. So all of these are, I'm trying to explain the concept that is so central to chemistry, that a mole is a very large number. It's 6.02 times 10 to the 23rd of whatever. Could be of atoms, could be of molecules. But it is just a number. So if you're asked, what is 1 mole of salt? You would say it's 6.02 times 10 to the 23rd molecules. Unless you are asked how much does something weigh, you never put grams next to it. So I find a lot of students will accidentally write, oh, it's 6.02 times 10 to the 23rd grams. Not so. It's just a count. If I asked you how many pens are these, you're not going to say 2 grams. You're going to say it's 2 pens. Same way. Okay? And remember that we use this in chemistry, and we can't use a dozen, simply because atoms are so small in size to begin with. So a picometer is like 1 trillionth of a meter. That's the reason why these atoms can fit in blocks this size, makes it more manageable. Questions you may want to think about. How do I know how many grams will give me a mole? I want you to hit pause. I want you to think about some other questions. Hopefully you've been able to write down a couple of questions. Now let me tell you one other question that you should be thinking about. How come copper looks a little bit different? And I'm telling you it's a lot heavier. So how would you know how many grams go into 1 mole for copper, and why is it different for aluminum? And why is it then even different for water or sodium chloride? So in the next video, I'm going to go over how you go about figuring out what mass or what weight, in this example, this is 18 grams of water. Why is it that 18 grams is equal to 1 mole? Why is it that 58 grams of sodium chloride is equal to 1 mole? That's what we're going to visit next in the coming video. If you found this helpful, make sure you smack that like button. Do me a favor. One of the best ways to learn this is to pay it forward and teach somebody else what I just went over with you. Also, I hope you took notes on what we discussed. And remember, if it ain't chemistry, it's just stamp collecting, okay? See you in the next video. Bye.
Funny how the story goes, little hope but bigger dreams.